Morning, it's afternoon for you, isn't it? Afternoon, everyone. Hope you're well. Hope you're staying safe from the storm. So today we are going to carry on with our forces topic. The idea of this video is that you can pause it at any moment to take your notes, to do questions. I just prefer it to Zoom because it means you can do the lesson at your own pace. You get everything you need to. If you need to ask me any questions, please feel free to email me. That's absolutely fine. I'll just be there monitoring my iPad. So let's start off today's lesson with some anagrams. Anagrams, if you remember, are just words with the letters all jumbled up, and you just need to figure out what the word is. So pause the video, have a little look at the anagrams, and then we'll go through them in a moment. Okay, hope you've had a chance to have a look at those. So the top one was acceleration. Number 2 was opposite. That was quite a tricky one. Opposite. Number 3, force. And number 4 was Newton. And today, if you can please write the title for me, which is Free Body Diagrams and Resultant Forces. It is not the 12th of March 2021. It is, in fact, the 18th of February today. So, yeah, don't write the 12th of March 2021. That was last year. It's not today. And we're going to start off with some practice free body diagrams. Now, you did free body diagrams last lesson. Just a quick reminder that to draw a free body diagram, you basically just, yes, I do want to write it with my Apple Pencil. Oh, lovely. You draw a dot to represent your object. So we did a feather last time, if you remember. So I'm just going to colour that in. Lovely, jubbly. So that was my feather, and then you draw arrows on it to represent the forces, and remember that the arrows should be roughly the right size for the forces. So for a falling feather, we had an arrow downwards, which would be weight, and we had an arrow upwards. That's really wonky, isn't it? They're meant to be down and up, sorry. And that was air resistance or drag, and they were the two forces that were acting on our feather. Just a reminder that when we had an apple and it was something sat on a table, so I'll put that over here. Again, I'm drawing that dot. I had an arrow downwards, again due to weight. But instead of air resistance pointing up, why can I not do up arrows at the moment? Everything seems to be wonky. Anyway, as opposed to air resistance, because it was sat on a solid surface, we had normal contact force. Do you remember? Normal contact force was that force that pushes back from a solid. So when I smacked the table, my hand hurt because the table pushed back on my hand. And that was normal contact force. So just a reminder, they're free body diagrams. So now we're going to do a few practice ones, which are here. Please ignore the fact that it says every single one of those words is spelt wrong. It's because I have my iPad set up to a Spanish language so that I can do my Duolingo, and therefore it tells me that every English word is basically wrong. Hey ho. So there are 3 practice questions here. I would like you for each one to draw me a free body diagram. Remember, blob for the object, and then draw your force arrows on and label them. Oh my gosh, I can hear the wind. Hopefully you can't hear that on the wind on this video. So pause the video, have a go, and I'm going to go through what they should look like in a moment. Okay, so I'm going to draw them on here. An egg is free falling from a nest in a tree. Don't worry, no eggs are harmed. Diagram the forces acting on the egg as it is falling. So I'm going to draw a blob for my egg. And very similar to the feather, we will have weight acting downwards. And because it is falling through the air, we will have air resistance or drag acting up. So hopefully that's nice and straightforward. Now, slightly more complicated, a gymnast is holding onto 2 ropes that attach to the ceiling. Diagram the forces acting on the gymnast. So I'll pop it down here. Again, I draw the blob for the gymnast. Again, I'm going to have weight acting down because we always have weight. But this time, we are going to have 2 arrows acting up because they are the ropes that they're holding onto. And those arrows I'm going to label as tension. Please excuse my husband just walked through, if you can hear that one. So 2 arrows, and we are going to label those as tension. Number 3, a rightward force is applied to a book in order to move it across a desk. Diagram the forces acting on the book. Now this is again quite a complicated one. We're going to draw a blob to show the book. As normal, we have weight. Hopefully you're getting the idea here. It is sat on a desk, so we will have normal contact force because that is the solid one, isn't it, that pushes back. So normal contact force. Then we've got side to side as well. So it is being pushed to the right. I'm just going to call that push. That's absolutely fine. So that is the force that it's being pushed to the right. And we will have a little bit of friction trying to stop it as well. Now, they did get more and more complicated there, but hopefully that's fairly straightforward and you remember that from last time. Now let's go on to today's lesson. Here I have a box and there are two forces acting on the box. I have 4 newtons pushing it to the right and I have a 10 newton force pushing it to the left. Now, a resultant force, which is what we're looking at today, is basically if I take into account all the forces that are acting on this box, what's kind of the leftover force? What's the overall one that's going to be acting? So I'm sure if you can see looking at this box, 4 newtons to the right, 10 newtons to the left, I would say overall I'm an idiot, that goes the wrong way. You are going to have a 6 newton force acting to the left. How do I know that? Because the two forces are acting in opposite directions, I'm going to take them away from each other to work it out. So I just wrote that here. 10 newtons to the left minus 4 newtons to the right equals a 6 newton force to the left. So what I would like you to do, please, is pause the video on this slide and write and draw this little diagram and the writing for me. Okay, hopefully you've all got that down. Now, I'm going to show you a series of slides and you just need to look at them. You don't need to do any writing here and just figure out what the resultant force is going to be. So the best way of me doing this is probably like that. Right, so here I've got a box, 2 forces acting on it. What's the resultant force? Hopefully you're happy that it will be 1 newton to the right. I know that because I just take them away. Next one. Okay, hopefully you're happy that it would be 3 newtons to the left because you do 6 minus 3. Remember, these are acting in opposite directions. That's why I'm taking them away. Okay, next one. Okay, you can see they're the same size. That means there is no resultant force. 5 minus 5 is just 0. No resultant force. Ooh, trickier one. Now the answer here is not 3. If you got 3, you need to check the directions of those arrows. Can you see they're both acting in the same direction here? That means I'm going to add them together as opposed to take them away. So the resultant force here would be 11 newtons to the right. Okay, hopefully you've got that it is 5. You've got 2 arrows, they're acting in opposite directions, so you take them away from each other, 5 newtons to the left. Ooh, it's got more complicated. Now my tip here is to treat up and down separately to side. So treat them as 2 separate things. Okay, hopefully you've been able to figure out for me that you've got 1 newton up, 1 newton down. They would cancel out, so there'd be no resultant force up or down. And then you do 9 newtons, take away the 2, leading to 7 newton force to the right. So we're doing 1 minus 1, the up and down, they cancel out. And then 9, take away 2, 7 newtons to the right. Okay, and this will be our most complicated one and will lead on to our next set of notes. So you have 6 newton and 5 newton up and down. So hopefully you can see that there will be a 1 newton force acting up. 1 newton force acting up. And you have 8 newtons to the left, 7 newtons to the right. You are going to have a 1 newton force to the left as well. Now I currently have 2 resultant forces there. And the whole point of a resultant force is you actually only ever would have 1. So I need to find a way of putting these 2 together. Hopefully you're happy that this would be moving up like that. If something's pulling up, something's pulling to the left, that box would move kind of up and left. Now, to find the size of it, we're actually going to use something that you use in maths, and that is Pythagoras. So hopefully you remember Pythagoras, a squared equals b squared plus c squared. We're going to be using that, so get your maths brains on for me. So in a second, I'm going to talk you through this slide, and I'm going to get you to then write all of the notes including the diagrams from this slide. So it's a title, Calculating the Resultant of Two Forces at Right Angles. You must use Pythagoras' theorem. Rearrange your arrows to make two sides of a triangle. So here's my two arrows, the 1 Newton and the 1 Newton. And look, I'm just using them to make two sides of a triangle. I'm then going to draw in the hypotenuse. Now, if you can't remember from maths, the hypotenuse is the longest side of the triangle, which is that bit. I'm calling it hype. Then use side squared plus side squared equals hype squared to find your hypotenuse. Now in maths, if you prefer, you can always go a squared equals b squared plus c squared. Now here, our hypotenuse is the a, and then the two sides are the b and the c. So if you don't like side squared plus side squared, you do a squared, b squared, whatever you prefer. They are your notes, you write down what you prefer. So the hypotenuse squared, or a squared, is 1 squared plus 1 squared. Hypotenuse is therefore 2. To get the hypotenuse on your own, you're going to have to then square root it, giving us hypotenuse is the square root of 2, 1.4 newtons. Okay, so there's a lot of writing on that slide. Please pause the video and write down your notes. We're then going to have a bit of a practice. So here are three practice questions. Please again pause the video, have a go at these practice questions, and we'll go through the answers on the next few slides. Okay, hopefully you've had a go at that. So number 1, how do I go back on this crazy thing? A squared is b squared plus c squared. The two sides are 10 and 7, so our hypotenuse, or our resultant force, is 10 squared plus 7 squared, so that's 149. We then need to get A, you then do the square root of 149, and it gives you the answer of 12.2 newtons. Next one, two sides of 10 and 12. So again, to find A, you do 10 squared plus 12 squared, so that gives you 244. A is the square root of 244, which gives you 15.6 newtons, which I've just rounded up there to 16. And our final question is, a squared is 6 squared plus 4 squared, so that's 36 plus 24, which gives you 60. A is then the square root of 60, which gives you 7.2 newtons. Okay, hopefully that was all fairly straightforward. There is a worksheet on Google Classroom for you to have a go at. If you are not sure about anything, please let me know. I'm always available by email. Hope you have a fabulous half term if I don't see you again. Goodbye, everyone.